Yeah, good afternoon all. Now I would like to discuss about nodal analysis. Okay, in nodal analysis, step 1, here we need to identify number of junctions. Identify the number of junctions. Okay, next step 2, assign node voltage with respect to the ground. Okay, assign node voltage with respect to ground. That means we need to identify the number of junctions. Okay, after that we need to assign node potential, and on those node potentials one should be a ground. Okay, we need to give node voltage with respect to the ground. That means one should be act as a ground. Next, step 3, assume node potential or node voltage is greater than remaining voltages. Step 4, by using KCL first, and Ohm's law next, to write node equations. Okay, that is about nodal analysis. Okay, to understand all those points, let us consider one circuit. It is having a battery voltage of V1 minus plus V1 R1 R2 R3 minus plus V2. Okay, let us consider a circuit. First, see here, what is the step 1 here? Identify the number of junctions, right? Here, see here, it is having junction 1 and junction 2. Junction is nothing but interconnection of 3 or more elements, right? 1 2 3. Assign node voltage with respect to the ground, right? That means one has to be ground, right? Okay, unless otherwise specifically mentioned, always we need to consider this as ground in every problem. Okay, that means this here I can consider this as a ground, right? That means how many junctions are present? If I neglect this one, then the remaining will be only one junction is present. I am assuming that junction potential will be V. Okay, identify the number of junctions, identified. Assign node voltage with respect to ground. Assign node voltage with respect to ground, right? This is node voltage with respect to ground. Node voltage with respect to ground. Node voltage with respect to ground. Okay, next, assume node potential is greater than remaining voltages. That means my assumed potential, what is the my assumed potential? V, right? V potential is greater than remaining potentials in the circuit, that is V is greater than V1 comma V is greater than V2, right? Okay, that is the third step. After that, by using KCL first. Okay, KCL means here I am assuming current I1, I2, I3. Okay, I am assuming, right, at this point I am assuming three currents are flowing, that is I1, I2, I3. All these three currents directions are outgoing only. Sir, why you are giving outgoing only means, see here, my assumed potential is greater than remaining potentials, that is my assumption. Okay, then current will flow from higher potential to lower potential, right? This is higher potential when compared to remaining potentials. That means current will flow from higher potential to lower potential, higher potential to lower potential. Current is flowing from higher potential to lower potential, right? Then based upon my assumption only, these are the current directions. Okay, by using KCL first and Ohm's law next, write the nodal equations, right? Now see here, apply KCL at junction V. All are outgoing currents, right? And you will get I1 plus I2 plus I3 is equals to 0. Okay, after that here I1 is equals to the potential difference. Okay, in this branch the potential difference will be V minus V1 by R1 plus I2 is nothing but V minus ground potential will be 0, right? That is V minus 0 by R2 plus I3 is equals to V minus, your potential will be V2, right? V minus V2 by R3 is equals to 0, right? From this equation you need to calculate node voltage V value. You will get node voltage V value some volts, right? After that, by knowing this V value, I can calculate I1 value. That means current flowing through resistor R1 is nothing but I1, right? Okay, I1 can be written as V minus V1 by R1. Okay, similarly current flowing through resistor R2 is nothing but I2, right? That is I2 is equals to V by R2. Similarly current flowing through resistor R3 is nothing but I3, right? And current flowing through resistor R3 is I3, right? That is I3 is equals to V minus V2 by R3. Okay, in this way we can calculate current flowing through any resistor or current flowing through any voltage source also. Current flowing through this voltage source will be I1, right? Similarly current flowing through second voltage source is I3. Okay, in this way we can calculate current flowing through any branch by using nodal analysis. Okay, thank you all.